So in today's video, it's going to be a short one, just going to supplement the reading that you're going to be doing and supplement the activity that you just did, talking about chemical and physical changes. I do want to start off just talking about different kinds of properties, and then we can get to the changes in a few moments. So the properties that we have are broken down in two different dimensions. And the first dimension that we break properties down in is same as with the changes into physical versus chemical changes. So physical changes and chemical changes. Now, I want to make clear that when we talk about properties and we talk about the changes, we're going to be talking about using pure materials, either elements or compounds. When we talk about separations in a few moments, then that's going to be how to separate a mixture so that we can recover the pure compounds or elements. So a physical property is one that describes how a substance appears. Remember that substances are another word for pure materials, how a substance appears. So we're talking about things like color, mass, temperature, things that are not necessarily indicative of how they're going to behave, how they're going to change. And that's what a chemical property is, how a substance changes. And these are going to include properties such as flammability, like gasoline, reactivity, how easily does a compound or an element react, tendency to rust or oxidize, a whole host of other ones. And these are going to be things that will apply to chemical reactions. The other property dimension that we can talk about is extensive versus intensive. And pay attention to the prefixes because those are going to be important. So extensive properties. So extensive is a property that's really not necessarily a property of that material. It's outside of the material, ext being outside. So extensive properties then are going to be properties that depend on the amount. But they're not going to be very useful for separating different kinds of compounds or substances into identifying them according to their different types. Excuse me. So mass, volume, length, these are things that depend on the amount, but they're not very good for differentiating. So I can tell you I have a kilogram of something, and that really doesn't tell you anything about it. Or something is 3 meters long. Again, that doesn't tell you anything really about the material. Although quantitatively, when we start making measurements and proving or demonstrating things like the conservation of mass, these extensive properties are going to be important. Intensive, I like to think of these as like internal. Use that same prefix, internal properties. These are properties that do not depend on the amount. Instead, these are properties that are more likely to be used for identifying substances. And we're going to see this in our density lab. We can use the density of a material to identify it, the color of a material. Now, color can be thought of as a physical property, which we saw up above, but a color change is going to indicate a chemical property because it's going to indicate that we have a different material. Temperature is an intensive property. It doesn't depend on how much you got. We'll find out about that as well. Freezing point, melting point, those are going to be important factors for identifying materials as well. So then in your activity the other day, we saw a number of physical and chemical changes. So physical changes are going to be changes such as cutting, twisting, folding. These are changes in which no new materials are formed. No new materials, just the materials you have there sort of rearranged or somehow they're made to have a slightly different appearance. And remember that we talked about dissolving. as one of the most important ones in chemistry, and that I believe was card G, where we took the sodium chloride and we made it into sodium chloride, the solid, and we dissolved it in water to make sodium chloride aqueous, and the ions came apart. So we will talk more about this. We will see this in our lab on Wednesday. So hopefully that'll help you make sense of that. Chemical changes are changes such as you burn something, you burn a log, most of the log disappears, and we'll talk in the lab about candle burning, where that log goes to, oxidizing, decomposing. In all of these, we have a new substance. And that new substance, there's going to be hints to identify the new substance, a new color, or formation of a solid or a gas in a liquid, color change. We'll talk about these again in reference to our lab this week. Conservation of mass tells us that matter cannot be created or destroyed. And so what's going to happen is that any mass that goes in must also come out. So mass of the reactants has to equal the mass of the products. And we will see this in a lab later on in Unit 3. So that's going to help to supplement what you're going to read in the book, and hopefully to put a little bow and tie up the activity that you did. Now, in order to get pure materials, we need to be able to separate mixtures. So separating mixtures into pure materials. Now, how we're going to do this depends on the different kinds of materials we have, because in order to separate materials, let me just scroll down to there. In order to separate materials, we have to make use of different physical properties differences in physical properties, because we don't want to change the materials chemically. We just want to get them physically separated. So these are going to be mixtures. Remember, we talked about in a mixture that mixtures retain the chemical and physical properties of their constituents. So we want to separate them according to something that's going to make sense to us. In this first separation, filtration, we can get solid from a liquid. So in this beaker up here, we're going to have little bits of solid. And so what we do is we have a piece of filter paper. It's like coffee filter. And you'll see this in a later lab where the solid stays behind and the liquid, called the filtrate, goes on down. And then this liquid can be a solution. And anything that has molecular or atomic size particles will go through. And anything that has larger particles, the larger particles get stuck in the filter paper, just like coffee grounds get stuck. Filtration, you can also think of things like pasta in water. The holes in the colander allow the water to go through, but the pasta is too big to go through. So this is a filtration. This is a technique, separation technique, that you've probably seen before. We're using physical size as the way of separating these. Distillation is if we have two soluble liquids. So these are two liquids that are soluble in each other. In this class, we're not going to run into needing to separate liquids that are insoluble. There's a technique, but I'm not going to discuss it unless we need to get through it. In this case, what we're going to do is, because the two liquids have different boiling points, we're going to try to separate these according to their boiling point. And the way that's going to work is, I'm sorry, I've got this workspace thing that just came out. There we go, get away. Is when we heat up using a Bunsen burner. And so we have salt water here. That's also a way of separating the liquid. So in salt water, we're trying to separate the liquid, but we can also separate two liquids. So this is if we want to collect, the liquid over here. And what we're going to do is we're going to collect the liquid that has the lower boiling point. So the lower boiling point comes off first. The lower boiling point, and in this case, water has a lower boiling point than salt. Salt does have a boiling point. So the water comes up here in the form of steam, and the steam comes into this condenser. In this condenser, we got cold water coming in. So cooling water, don't worry about that Liebig or Liebig condenser. Just the idea here is that now we recondense the water, and the water then drips into our collection flask, and we've collected one of the liquids. So this is a way of collecting the liquid. Now, suppose we want the solute, we want the salt. And with that case, we're going to separate the solid from the liquid using volatility, which is really the ease of evaporation. It also depends on the boiling point, but we usually don't think of salt as having a boiling point because we usually don't see it in a liquid form. So in this case, we have, say, a solution. Again, this could be salt water. And we heat it up. And as we heat it up, the water is going to evaporate off. And eventually it's going to leave just the crystals of salt behind. This is a way of separating salt from seawater. And they have big farms, if you'll call them that, for separating salt from seawater and making sea salt as the water evaporates. Finally, we will also use this technique called crystallization, where we have a solid coming out of a liquid. So what we're going to do is separate this by solubility, and usually that means changing the temperature to change the solubility. And we'll learn more about that later on when we talk about properties of solutions. But in an ice bath is always going to be at 0 degrees Celsius, and we'll talk why later on in the year as well. And so what happens is we can crystallize in the bottom of this flask. We'll crystallize some of the crystals. Once we do that, we then have to follow this up with filtration or somehow getting rid of the liquid and having the solid left behind. So these are just a few of the separation techniques that we're going to be making use of during the year. Again, always based on some difference in a specific physical property. So in the homework, when you're doing the homework for this, please think about what are the differences in physical properties that you can use to separate the given materials. All right, so that's it for the asynchronous lesson today. And if you have any questions, please don't hesitate to let me know. Otherwise, I'll see you in class next time. Take care.